Thank you for coming back for our 9th video in our integration series. This video is going to be talking about the area between two curves. So first we're going to start off with a graph. So say we have two curves. They don't necessarily have to look like this, they could look like other functions as well. Where we have f of x and g of x. The integral between points A and point B, in between these two curves, can be evaluated as the area that's beneath the entire f of x, where g of x is contained within f of x, minus g of x. So the area between this curve is equal to the integral from a to b of f of x minus g of x. Now we also have to keep in mind that if a function takes over another function, say if we have a very simple function, and we wanted to find the area between this point and that point, we need to find two different integrals. We have to find the integral between the difference between this and that up until this point A prime, and then from that point up until that point, where our integral, which was beneath the first integral, is now the first integral, and then our integral that was on top is now the second integral, and you find the difference between a prime and b. And the way that we would write this is the area is equal to the integral from a to a prime. Let's say that our first function is f of x and our second function is g of x. F of x minus g of x. Now we have to add a second integral together. So a prime and b of g of x minus f of x. And this can be repeated as many times as a function takes over another function. So we're going to do an example of both. Our first example is a very simple one. So we need to find the area between y is equal to x and y is equal to 2x between x equals 3 and x is equal to 6. So the first step is to find out which one is on top during this interval, and also whether or not one of the functions will overtake the other function within that interval. So we can do this simply by evaluating these functions within the intervals. It's simple for a linear equation. It's a little more involved for something that's not linear. But we can easily see this because these are linear. So our range is between 3 and 6. And our range for this is between 6 and 12. So we can see that y equals 2x always overtakes x within this interval. So here we just have to do one simple integral, 3 to 6 of 2x minus x is equal to the integral of 3 to 6 of x dx. Let's not forget the dx. The integral of x is equal to x squared over 2. And now because this is a definite integral, we're going to write in this notation to evaluate the integral at these 2 points, between these 2 points. So x squared, so 6 squared is 36 over 2, minus 3 squared is 9 over 2, and we end up getting 12.5. So often with these, you'll just have to plot these. And often you'll have to, if you don't have a calculator or a computer, you'll have to sketch these using differentiation techniques that will give you very basic sketches of both plots, and you can see approximately where functions overtake one another, and so on and so forth. So this example is going to be where it's going to be a very simple example where we really don't have to do much, but we get to get experience using this as well. So here we're finding the area between y is equal to x plus 4 and y is equal to 2x minus 4 from x is equal to 0 to x is equal to 8. Okay, so these are both linear equations, so once again we can check the values of each of these functions. So y at 0 is equal to 4, y at 8 is equal to 12, y at 0 is equal to negative 4, y at 8 is equal to 12. So instead of using 8, let's extend this to 10 so that we can also get y of 10 is equal to 14 and y of 10 is equal to 6. So here is where the functions meet up. So our first interval is going to be x equals, so our first interval is going to be x equals 10 to x is equal to 8. And our second interval is going to be x equals 8 to x is equal to 10. And the next step is to figure out where each function takes the other. So in our first interval, x is equal to 0 to x is equal to 8, this function is dominant. So we can put this on top in our, this first, in our first integral. And then in is equal to 16. And in our second integral, our second function is dominant, so we'll be using this as our first function. So let's do that. So the area between these two curves is the integral from 0 to 8 of, this is our dominant, so x plus 4 minus 2x minus 4 plus dx plus the integral from 8 to 10 of 2x minus 4 is our dominant integral here, so 2x minus 4 minus x plus 4 so that gives us the integral from 0 to 8. X minus 2x is negative x. 4 minus negative 4 is plus 8. Dx plus the integral from 8 to 10. 2x minus x is x. Negative 4 minus 4 is minus 8 dx. So then we just simply find the integral. So we have negative x squared over 2 plus 8x evaluated from 0 to 8 plus x squared over 2 minus 8x evaluated from 8 to 10. And that integral is equal to 34. So the area between these two curves within this interval is 34. Okay, so just to recap, if we have a function like this where one function is always dominant, it's very simple to evaluate. You just have to take the top function minus the bottom function. But in a function like this, example that we just did, our interval that we wanted to evaluate was from 0 to 10. However, from 0 to 10, at 0, this is dominant. At 10, this is dominant. At some point, the two functions crossed. Using our principles of algebra, namely setting these functions equal to each other, x plus 4 is equal to 2x minus 4. We can get that these two functions are equal at x is equal to 8, which we have confirmed. So at x is equal to 8, the two functions switch places. And so kind of as an example, they're obviously not curves. But here we can see kind of an illustration where one function overtakes another function that was originally on top. So here we have to evaluate from where our initial point is to where the function overtakes the other function, and then from where the function overtakes the other function to either one of two places, where the function overtakes the function overtakes the function again, or if the function or if the range ends. So once again, thank you for coming back and watching, and I look forward to seeing you guys again soon.